Good morning, everyone. Welcome back to Sri Chaitanya Educational Institute's channel and welcome back to our bridge course for our target exam of NEET 2026. Yes, good morning, everyone. All right. So, in our journey so far, what we have studied, we have taken the part of mechanics and we have started mechanics with our fundamentals of kinematics. I hope you understand the flow. For all the new learners which have joined recently, maybe in this session or maybe in last to last session, I would suggest you that spare out take out some time from your daily schedule and go through all the videos in the playlist, because you are going to learn a lot and this learning is going to benefit you in a variety of topics and chapters of your NEET syllabus. All right. So here, till now, so far we have discussed the Galileo's formula, the basic average and instantaneous value concept, the graphs, the use of calculus in graphs. Then we have talked about motion in 2D, horizontal projectile motion, oblique projectile motion, a lot of problems based on that. Apart from that, then we discussed the relative motion. In our last interaction, we have talked about relative motion, relative velocity, a very different technique or tool to deal with a number of models in kinematics or in physics in general. So when I was teaching you the relative velocity, I kept on saying that it is not a separate topic, but it is a tool or a technique, I would say. Because as I always say, all the questions that can be done with relative velocity can also be done without relative velocity. But few are the models which you need to do, which you better do by relative velocity only. Those models are riverboat problem, rain umbrella problem, time of crossing, time of approach, ship model, like distance of closest approach, many things are there. All right. So we have introduced the concept of relative velocity last time, and I also emphasized on the point the students are confused about. That is, what is the core difference between dealing of effective velocity and dealing of relative velocity. So I hope those fundamentals are clear to you. Now today we are emphasizing on another topic which is generally a confusion or a problem for the students, that is riverboat problem, relative velocity model, first model, riverboat problem from kinematics. All right. So as the heading itself suggests, it's a river and a boat problem model. River and boat problem model. So instead of boat, there could be a swimmer also. Okay, so inside the river, there could be a swimmer also. So what is the basic difference between observing a motion on the ground and observing the motion in a river? So river is not a steady, is not a stagnant water body. It's a flowing water body. So when the boat is moving or when the swimmer is moving, its effective velocity will be given by the velocity of boat or swimmer in the river plus velocity of river with respect to ground. All right. So basically it's a effective velocity concept that boat is moving inside the river, a river is moving with respect to ground. So what is the net velocity of river with boat with respect to ground? You can get that by adding both the vectors, velocity of boat with respect to river plus velocity of river with respect to ground. So keep it in mind. I'm going to introduce the concept in front of you. Okay, so the basic concept is, first of all, I would like to talk about riverboat model or river and swimmer model in 1D and then in 2D. So in one dimension, in 1D motion means that is along a straight line, So if I have to talk about the straight line, then in that case you will say that you are dealing with two terms here. One is upstream velocity, one is downstream velocity. So if we are talking about the downstream case, downstream means along the stream. Downstream means along the stream. So basically the boat is moving in the direction of the stream or in the direction of the river. So downstream velocity, the net velocity of boat with respect to ground will be given by velocity of boat with respect to river plus velocity of river with respect to ground. Now, as I said, that downstream case means the boat and river both are moving in the same direction, let us say in the forward direction. So when you will substitute it, say the boat's velocity with respect to river is v, so this will be plus v, plus, and the river velocity with respect to ground is u, so it will be plus u. This implies the effective velocity is v plus u. Let me show it diagrammatically for you. So if I show that diagrammatically, I would say that, or let me write some symbols here. Velocity of boat with respect to river, velocity of boat with respect to river, its magnitude is v. Suppose, say we are assuming these things, and velocity of river with respect to ground means the velocity of flow of river, velocity of flow, that is its magnitude is suppose u. So these symbols I have used over here. Downstream actually means that the stream or river is moving in this direction, okay, and the boat is also moving in this direction. The boat or swimmer is also moving in this direction. So with what velocity the stream or river is moving, so velocity of river with respect to ground, its magnitude is basically u, and velocity of boat inside the river, its velocity is v, But now what I want you to understand here is, this is the downstream case, all right. I want you to understand that we are not interested in velocity of boat alone. We would be interested in velocity of boat alone when only boat alone is moving, and the water body in which it is moving, it's not flowing. For example, if the same concept I try to apply in the case of a pond or a lake, the same concept if I apply for a pond or a lake, the pond or a lake is a stagnant water body, it's a steady water body. But here if we talk about the river is a flowing water body. All right. So the boat is moving inside the water, but water itself is not at rest. Water itself is moving. So with what resultant or with what effective velocity the boat will be moving? How do we get that, sir? We get that by doing the vector addition. Over here. Is that clear? All right. Say one more time we want to see that. Okay. One more time. So now, and in case of upstream, if they say, see, and in case of upstream means here that the river flow and the boat's direction of motion, they are in opposite direction. So in case of upstream, if you are writing velocity of boat with respect to ground, that will be equal to, vectorially formula will still be the same, velocity of boat with respect to river, boat is moving inside the river, plus river is moving over the ground, boat is moving inside the river, plus river is moving inside the ground. If first is moving on second, second is moving on third, how first is moving on third, that's what you got, that how the velocity of boat with respect to ground do you get. Now, if I try to show that diagrammatically for you, then you will say that, see here, the stream is moving in this direction, or say the boat is moving in this direction. Boat is moving in this direction with velocity of boat with respect to river. Just a moment. Yeah. Here it is, velocity of boat with respect to river, and the magnitude of velocity of boat with respect to river is v. Okay, v. And this time the river is moving in opposite direction. Velocity of river with respect to ground and its magnitude, and that is u for our discussion here. Is that clear? So that is the case of in 1D motion and in 2D motion. In 1D motion and in 2D motion, we have to talk about the riverboat problem. The situation which is in front of you is only in the case of 1D. Now, according to the diagram, let us put the values. Let us keep the values. Velocity of boat with respect to V is V, and it is in the forward direction. So I'll substitute it as plus V, plus this plus because of the formula vector addition. And now velocity of river with respect to ground. We are assuming diagrammatically that a river is moving in opposite direction. So according to sign convention, that's minus U, and hence what you get is V minus U. All right. So that is the case of downstream. Downstream means along with the flow. Upstream means against the flow. Downstream, along with the flow. The meaning of downstream is along with the flow. Okay, along the flow of the river. And upstream means opposite to the flow. Opposite to flow. So when you are moving in the direction of the flow, see, here we are not talking about relative velocity. Last time I told you when the bodies are moving in the same direction, relative velocity is given by the difference. Here it's not relative velocity. Here it is effective velocity. So see that even if, since they are moving in the same direction, you are not going to have a negative over here. You are not going to have a difference. Rather, you are going to have a sum. Once again, I'll repeat my words. Listen to it very, very carefully. It is only upstream and downstream case in front of you. Today, we have to basically talk about motion in 2D, a riverboat problem, drift, time of crossing and all. All right, we will talk about it. But first of all, downstream means the stream and the body are moving in the same direction, or body is moving along with the stream in support to the stream. When two bodies are moving in the same direction, their relative velocities are basically given, the relative speed is given by the difference of the two. But here, when they are moving in the same direction, this is given by the sum. Why? Because here we are not talking about relative velocity. Here we are finally getting the effective velocity. I hope the confusion is clear. I told you last time. And here, similarly in case of upstream, if both the bodies are moving in opposite direction and you stand on one and observe the other, the relative speed is given by sum. But here, upstream means opposite to the flow. And if you are going to calculate the net velocity or effective velocity, it is given by the difference. All right. So I hope everyone is clear. There should be no confusion in that. Let me know. Is that clear for us? All right. All right. Let us move ahead. Now, we are going to talk about the same thing in 2D. 2D. The same concept I am going to talk about. But this time we will talk about the entire thing in 2 dimension. So here, right, these are the assumptions which are here only, and in fact I would say I'll show that diagrammatically for you. Now see, this concept, I'm saying that here, this is the river. This is the top view here. This is the top view of a river. W is the width of the river here. W is the width of the river. And there is no role of gravity. There is no role of gravity. This is in 2D, right? Concept in 2D. 2D riverboat. Last slide we have talked about 1D. Here we are talking about 2D. So there is no role of gravity. The reason is, by the river is flowing on the ground. This is our XY plane here, and we are taking a top view. Gravity is perpendicular to this motion. Gravity is perpendicular to the plane of the motion, and perpendicular vectors never contribute. I repeat, acceleration due to gravity, or you can say gravity is acting perpendicular to the plane of motion of a riverboat, right? Riverboat moves in horizontal, river also, boat also, like that. So gravity is not going to affect, gravity is not going to contribute in this model. So here what is happening, that river is moving in this direction, river is moving in this direction, and this is the velocity of river with respect to ground. Velocity of river with respect to ground, that is u. That is u. Suppose that is u, which we have already discussed. And suppose somewhere here at a point A, there is my boatman or the swimmer, and he wants to cross the river. And suppose he is moving in this direction with a velocity of boat with respect to river, or velocity of boat inside the water, which is given by v. Suppose that is given by v, and it is making this angle as phi. It is making this angle as phi. This is a situation for you. Okay. So I would say number one thing which can be asked to you here in the diagram is that exactly opposite point is B. Exactly opposite point is B over here. So there are two things. You want to see how much time this boat or swimmer takes to cross the river. How much time this boat or swimmer takes to cross the river? Question number one, time of crossing. Number two, when this boat or swimmer crosses the river, where it reaches. So suppose, let us assume that the boat or swimmer has already crossed the river, and I want to get the idea where the boat or the swimmer has reached. So from here, because of the flow of the river, there is a chance that it will travel some distance in the direction of flow. Because again, I will be repeating the same thing, that you are not dealing with a steady or stagnant water body. You are dealing with a flowing water body. So wherever you want to move in the flow of the river, or the flow of river is also going to influence you. This flow of river will influence you in this direction, and you will be reaching somewhere here. This distance, the distance traveled in the direction of flow from exactly the opposite point, that is called x, that is called drift. So number one, the first thing which they generally ask here is time of crossing. Time of crossing. Okay. TC. And number two, what they will be asking you here is drift, x. All right. So we will try to get both the idea, time of crossing as well as drift, how to get that. Now, what I want you to understand is, I hope the situation is clear. W is the width of the river. Velocity of river or velocity of flow with respect to ground is u. The velocity of boat or the swimmer inside the water is v. But the water itself is not steady, stagnant. Water itself is moving. Water itself is moving. So if water is moving over here, in that case, I would say that the effective velocity will be the contribution of both. Effective velocity of the boat from the ground, or observer is on the ground. Another thought that strikes is, sir, why you are interested in the velocity of boat or the swimmer with respect to ground? Because boss, the boat or the swimmer has to go from one bank to another bank, one point to another point. So these 2 points, the point of start and finishing point, these 2 points, these 2 banks are nothing but on the ground, no. So that's why we want to get the motion with respect to ground, although the velocities whose information we have is that what is the velocity of boat with respect to river and what is the velocity of flow of the river. So what you need to do with these 2 velocities in order to get the net velocity, we want to add them vectorially. Vector addition it has to be. Eventually it can be addition or subtraction, that depends on the diagrams, that depends on the cases, downstream or upstream. But the vectorially, for the vectors, you are always going to add them. Velocity of 1 with respect to 2 plus velocity of 2 with respect to 3 will give you velocity of 1 with respect to 3. Right? Now, let us talk about these two. So if I consider this particular diagram, I would say that, see, this V is here. I can break it like this. This will be V cos phi and this will be V sin phi. One is V cos phi and one is V sin phi. So here, what is happening? I will say that time of crossing, which velocity component is responsible? Which velocity component is responsible to cross the river? You can see the river must be crossed in this direction with no contribution of gravity. Gravity is perpendicular to this plane of motion and that's a top view. So time of crossing TC is given by distance by speed. The distance traveled in this axis is W and the speed in this axis is V cos phi. V cos phi, and that you have to travel in y direction. This thing you have to consider in y direction and not vertical. This y direction here is not vertical direction. Is not vertical. Generally, we have a habit na taking the y direction as vertical direction. No, no, no. Vertical is perpendicular to this plane of motion. Okay. So this is your x-axis, this is your y-axis, and none of them is vector. Here the xy plane, none of them is vertical. Here the xy plane is basically, this xy plane is basically horizontal plane. Yes, because the entire motion is happening on the horizontal ground. This is horizontal plane. Okay, so in y-axis we have talked about it. Now suppose we are interested in the x-axis, drift. So this distance will be, you will say whatever time it takes while reaching from here to there, time, which we have already calculated, into speed. So this drift x is going to be equal to time of crossing into speed in x direction. Now what is the speed in x direction? Who is trying to provide the drift? According to this diagram, this u is trying to provide the drift. This u over here is trying to provide the drift. And this v sine phi here is trying to prevent the drift. Focus on my words. It is trying to provide the drift. It is trying to prevent the drift. So it is going to be equal to u minus v sine phi. U minus v sine phi into, or you can say the time of crossing, which you have already calculated, that is w by v cos phi. W by v cos phi into the effective speed will be, this u is trying to provide the drift, this v sine phi is trying to prevent the drift. See, that's what you got. So these are the formula. These are the formula over here, which I don't want you to remember. Don't remember the formula. Don't remember these formula. Reason number one, these, like especially this formula, this doesn't seem to be a very nice or easy formula, right? Reason number two, no exact formula is printed or published in NCERT. You need to get the feeling behind it. What is happening, where the body is moving, okay, with what component of velocity is supporting the motion, opposing the motion, those things. These formula are not to be remembered. I repeat, these formula are not to be remembered. Try to feel it. And very soon, like on the next slide, I'll be giving you few examples where you will realize that you never know that this angle is made with what, or the boat's component of velocity is actually opposite to the u. This v sine phi is opposite to u. It's not necessary, no. Sometimes v sine phi can be supportive to u, obviously. Similarly, sometimes you will say that it is moving perpendicularly. Obviously, every case is possible. So even if you remember one of the formula, that's not going to fit in all the situations we are going to discuss. I hope that is clear what I am telling. So today, first of all, we have tried to understand the situation. I hope you understood. Now, we will try to see what are the modifications, what are the different cases. Then at last, I may tell you to remember one or two formula before we start with the problem solving. Just have a look. Take few seconds. See everything written on the board, and in fact, I want you to revise from here. Just take a quick recap. See everything written very, very carefully. Everything is clear? Now, let's go through this. See every minor detail, and wait, hold on for your doubts. I'll just show you different cases, different modified case situations. Then some one or two special cases I would tell you to remember. This is the general case. Don't remember any formula. Done? Okay. Chaliye. Let's move on to some different situations over here. Now, case 1, example 1. let me say that, let me take it this way, that this is the velocity of river with respect to ground. That is going to be u. And here, suppose the first basic modification, it's not necessary over here that, you know, the angle is made with this direction. The angle may be made with this direction. I mean, this is the width of the river, W. This is the width of the river. This is the velocity of river with respect, this is the velocity of boat with respect to river. You know, exactly the same situation. The only difference is, instead of making this angle as phi, I would be making this angle as phi. Because we never know what examiner is going to give. That we have to read the language, English of the problem, then draw the diagram, and then you can talk further. So this is point A, this is point B, and say by traveling a distance x, you might reach a point C over here. So examiner would be asking you two things. Number one, they will be asking you the time of crossing. Number two, they will be asking you the drift. All right. So let us see both of them. I'll be writing both of them like this. So first of all, I'll resolve the velocity here. I will say that this is VBR, which is V. So obviously this component, the axis, the axis with which the angle is made, that axis will carry cos component, perpendicular axis will carry sine component. So this is V cos phi, and it is going to be V sine phi. What will be the language of the problem for this diagram or situation? They will say the boatman or swimmer is making an angle phi in opposite or with opposite to the current of the river. Current of the river or flow of the river is in this direction. Opposite to the current is in that direction. With that direction, you are making an angle phi over here. Okay. So the first thing what they can be asking you is time of crossing. So you will say time is given by distance upon speed. There is no acceleration in this picture. There is no effect of gravity in this situation. So time of crossing will be distance upon speed. The distance to be traveled is the width of the river in order to cross the river. By the speed with which it is traveled is V sine phi. V sine phi. If they are asking you the drift x, then you will say the drift x will be speed into time, but in x-axis this time. So who is trying to provide the drift? The u is trying to provide the drift. Who is trying to prevent the drift? Who is trying to prevent the drift over here? V cos phi. So it is u minus V cos phi into time of crossing. So that will be equal to u minus V cos phi, u minus V cos phi into W by V sine phi. I hope this situation is clear to you. So if you compare it with the last discussion we had, it is clearly noticeable that sine and cos have interchanged their position. So sine and cos will be exchanged. Look at these results carefully, very, very carefully. Look at it. You don't have to remember these. Don't remember these. Okay. Now just look at these results. See, it was W by V cos phi. Here it is W by V sine phi. Here it is u minus V cos phi into W by V sine phi. Here it is u minus V sine phi into W by V cos phi. So sine and cos have interchanged their position. You never know what examiner can give you. Okay, so today we will do a lot of problems. We will read different languages. We will try to draw a diagram, and then we will carry forward the discussion. But as of now, I would say that you have to understand these different situations. Don't memorize those results. Let me give you another example here. So now what is happening? It's not even necessary that the the boatman or the swimmer will try to oppose the flow. It might try to support the flow. Now the language of the question is, there is a river of width W. There is a river of width W which flows with a velocity V. So this is velocity of a river with respect to ground, which flows with a velocity U, suppose. That flows with a velocity U. On one bank of the river at point A, the boat or the swimmer starts with velocity V. So this is velocity of boat in still water. Velocity of boat with respect to river water in still water, you will say that is basically equal to V. Making an angle phi with the flow of the river. Here this angle was made with opposite to the flow. Here this angle is made phi with the flow of the river. Determine the time of crossing as well as the drift produced. So definitely this time it is also supporting. They make an acute angle. So drift is going to be huge. drift is going to be huge over here. So this is x, and this is t equals to 0, and this is t equals to tc, time of crossing. Okay, so you have to tell me the same two things again. One will be the time of crossing, one will be the drift. So the first thing what you are going to do over here is what? You are going to do over here, vector resolution. I will say this v is making an angle phi with the flow of the river. So this component will be v cos phi, and this component will be v sin phi. I hope everyone is comfortable with it. Now the first thing they are asking you is time of crossing. Just like in projectile motion, you always calculate the time of flight first, then you multiply the time of flight with the horizontal velocity in order to get the range. Similarly, here you always calculate the time of crossing first. When you got the time of crossing, multiply it with the effective velocity in the direction of the flow. So you will get you'll get the drift. So time of crossing will be distance w, which it has to travel to cross the river, by with what velocity it has to cover, v sin phi. And here if they are asking you the drift, then I'm going to multiply the effective speed in x-axis. So this time this v cos phi is in support to you. Here this v cos phi was opposite to you, but here it is supporting to you. So this will be u plus v cos phi. This time no one is trying to prevent the drift. No one is trying to prevent the drift. Both are trying to provide the drift. Okay, into tc. Now just substitute this value tc over here. You will get u plus v cos phi into w by v sin phi. I hope you are getting the feeling what to do, how to do. All right. I don't want you to remember any formula out of this. Another example I will take, but I really don't want you to memorize any formula. I want you to understand the approach. Every time what I am doing, I'm taking a situation. While dealing with the question, I'll read the question. I'll draw a nice diagram. I'll resolve the vector. Then one by one, I'll calculate the first step first. I'll calculate the time of crossing first. Then I'll be getting the drift. All right. Chaliye, let's talk about the next one. Now here, I can still change the angle. Let me take, let me change the angle. This is A, this is B, this is W, and this time, this is moving velocity of boat with respect to still water, that is V, and this angle is phi over here, and the river is flowing in this direction with velocity of river with respect to ground, that is U. Okay, I'm not writing again and again vector sign over them because I know that I have separately mentioned the magnitude as well as the direction. This is V, and that's U. Let me write it as V naught. So first step first, what you need to do, resolve the vector. So I will say this time this component will be V naught cos phi, and this component will be V naught sin phi. I hope everyone agrees. With whichever axis the angle is made, that axis will carry cos component, perpendicular axis will carry sin component. All right. Then time of crossing. Now you tell me which velocity component is responsible to cross the river. So this V naught cos phi is responsible to cross the river. So here Tc will be equal to W by V naught cos phi. And in this time in which the boat is flowing through the river, crossing the river along with its flow, the river will also put its own influence. A river will try to make the boat move in the direction of its flow. So it will be reaching somewhere here. The distance x, and this x is given by the speed, the effective speed in this direction, u plus v naught sin phi into w by v naught cos phi. I hope that's clear. You have multiplied the effective speed into the time of crossing. That's what you have been doing in all the cases. Read the language of the problem. Riverboat problem is very easy. We will see a lot of numericals very soon. Read the language of the problem, draw a proper diagram, resolve the vectors, talk about time of crossing, talk about the drift. I hope that's clear. If you want, you can take the screenshot also and just go through everything written on the board. See everything, every case, 3 cases are there. Don't remember any of the formula. Don't memorize the formula. Remember the approach, what to do. Okay, done, sorted. Now, now I would tell you to remember two cases, and these are the special cases. So in these special cases, definitely I'm mentioning, I want you to remember them. Remember all results here. Remember all the results here. These two cases one by one we will talk about. Obviously you will understand this also, but if that is the special case, I'm calling it a special case, so let's give it a special treatment. Till now I didn't say to remember, I didn't instruct to remember any of the formula in today's lecture till now. Okay, now one by one I'll explain these cases to you. You will understand it well, but at the same time I'm instructing you to remember these results. It is going to save a lot of time in the NEET exam if any question comes from this topic, and definitely we are expecting. Okay, so minimum time condition, minimum time condition. See, if imagine that you are a swimmer, try to feel it first. Imagine that you are a swimmer or a boatman and you are trying to cross the river. Okay, if your main intent is to cross the river, as early as possible. Suppose weather predictions are done, it's dangerous to stay for a lot of time inside the river. So your prime concern is, I want to cross the river, and I want to cross the river at the earliest. Exactly where I will reach on the other bank, that doesn't matter, that doesn't bother me a lot. But my intent could be that I want to cross the river as soon as possible. So that situation is minimum time condition. Another situation is that my priority is that I want to start from here and I want to exactly reach the opposite point. I want to exactly reach the opposite point. How many days, how many hours, how much time it takes, it doesn't matter to me. All right, understanding what I'm saying? I'm saying two different intentions or planning. Planning number one, I want to cross the river in the minimum time, means as early as possible. Then you can't reach exactly the opposite point. I'll explain it why. But first of all, understand these two plannings are separate. One can be fulfilled at a time. Both can't be attained at a time. Okay? Because river is flowing. River is not stagnant. It is a flowing water body. So inside a river, these two cases will not coincide. They will be different plannings. So planning number one, I want to cross the river as soon as possible. Wherever I reach, where I exactly reach on the opposite bank, it doesn't bother me much. It doesn't matter to you. And obviously you will not be reaching exactly opposite point. You'll be having some drift because, as I said, these two plannings can't coincide. But where I reach, it doesn't matter. Similarly, planning number two. Planning number two is I want to exactly reach the opposite point. Then in that case, your time taken will not be minimum. Then in that case, you will be having some time taken. Okay, what will be that time? Which will be more than this minimum time. We will see that also. Don't worry. But three things on this slide before I start. Point number one, I want you to feel it, but I want you to remember the results. Point number two, these two plannings will not be, these two cases cannot happen simultaneously. That means when time is minimum, drift is not minimum, and when drift is minimum, time is not minimum. Point number three, their plannings and intentions are different. Accordingly, you will decide where to move. Either you want to cross the river in the minimum time, so wherever you reach, it doesn't bother, it doesn't matter to you. Or I want to exactly reach the opposite point. Then how many more number of hours you take, it doesn't bother you, it doesn't matter to you. I hope the planning, the intent is clear. Okay, now let's talk about one by one. So logically speaking, if you want to have your minimum time condition, you want to minimize the time of crossing, then 100% efforts must be directed. 100% efforts must be directed in order to cross the river. Complete efforts. 100% efforts are directed to cross the river. To cross river. That is, That is, diagrammatically, if I try to explain this, so you will say this is the river, this is W over here, and this is the velocity of river with respect to ground. Okay, that is U. 100% efforts, if you want to put the to cross the river, then where you should move? You should obviously move in order to cross. So you will be having this velocity of boat inside the river, and that is equal to V, and that is equal to V. So what you can see clearly here is that velocity of river is an x-axis, velocity of boat, since you want to have 100% over there, this angle phi is going to be 90 degrees. That is, V vector must be velocity of boat, or this V must be perpendicular to U. This V must be perpendicular to U. This is something I want you to remember here. This is basically the condition. What condition, sir? This is the condition for minimum time. Condition for minimum time. Condition for time of crossing to be minimum. Condition for time of crossing to be minimum. Okay, sir. Condition is fine. Condition is fine. We have understood that we want to keep our 100% efforts in order to cross the river. Where we reach, it doesn't bother us much, but we still have to see that from here, then from here, you will be moving in the direction. You will be flowing in the or moving forcefully in the direction of the river. This forceful motion is called drift. All right. This forceful motion is called drift. So this is t equals to 0. This is t equals to Tc, which is minimum according to the case. Okay. And the direction in the direction of the river flow, what distance did you travel? That is called as drift. So two things over here. Two more things over here. Number one, I will be talking about the time of crossing. So time of crossing will be equal to what distance you have to travel in order to cross, that is W. And with what speed you want to cross, that is V. With what speed you want to cross that is V. Can I keep it V not everywhere so that, there will be a difference in writing V and U. Otherwise, sometimes my writing V and U are similar, look similar. Okay. So here, this is the situation entirely. Now they are asking you what will be the value of this drift. What will be the value of this drift X? So I will say effective speed in the direction of flow into the time of crossing. So effective speed in the direction of flow is U, and the time of crossing is W by, let me write it like this, into Tc. So that will be further U into W by V naught. I hope my entire explanation is clear to you, but still I would suggest you remember everything. So three things to be remembered here. Point number one, in minimum time condition, point number one, if you want the time of crossing to be minimum, then definitely your 100% efforts will be directed in order to cross. And when you cross, so that is the condition. And when you cross, then what time do you practically take to cross? That is W by V naught. And in that time, how much you have flown in the direction of the river because of the forceful nature, because river has forced you to flow or move in the direction. So that is U into Tc. I hope that is clear. All right. Now I'll compare it with the second one, that is minimum drift condition. Minimum drift condition. Now what will happen here? You want to minimize the drift. So basically you want to nullify the effect of reverse flow. So this is river flow. You want to compensate. So this is the flow of the river. Velocity of river with respect to ground, that is U. All right. This is point A. This is point B. Exactly opposite. Exactly opposite like this. And in the flow of the river, this will be point C. But you don't want any drift. This time minimum drift condition means you want to exactly reach there. So this velocity is velocity of river, velocity of boat with respect to river, and that is equal to V naught for our discussion. And let's say this angle is phi. Remember, dear, that angle could be this phi or angle could be this phi. That depends on the examiner. So when I tell you to remember all these results, no result here should be in terms of phi. Similarly, no result here should be in terms of phi, because phi may change in the question to question. But special cases, no result. I want you to remember these results, but no result should be in terms of phi. Last time we have all the results, but every result is in terms of phi. So I don't want you to remember these, because that will keep changing, right? All the cases. But here that's gonna be fixed. So I will say, right. I'll just resolve these velocities. So I will say that this will be my V naught cos phi, and this will be my V naught sin phi. This will be my V naught cos phi, and this will be my V naught sin phi. If you want to nullify the drift, minimum drift, then definitely the velocity which is trying to provide the drift and the velocity which is trying to prevent the drift, providing the drift and preventing the drift, they must balance each other, which means this must be equal to this. They must balance each other. So I will say condition is that V naught sin phi here must be equal to u, or sin phi will be equal to u by V naught, or phi will be equal to sin inverse u by V naught. It could be cos inverse also. Right now it is sin inverse because the angle is this and this is V sin phi. Otherwise, remember this approach, it could be cos inverse. Possible, this situation is possible to have minimum drift only if sin theta or sin phi is less than equal to 1, or you can say u by V naught is less than equal to 1, or u is less than equal to V naught. Means both should be more powerful. That is, boat should be boat or swimmer, boat or swimmer is more powerful. I'm just trying to give you the sense of interpretation here. Suppose you are the boatman or the swimmer and you are swimming inside the water body, river basically, but the river is more powerful. So if the river is more powerful, even if you try to exactly reach the opposite point by providing some opposing behavior, but since river is more powerful, despite your efforts, the river will definitely make you flow in its direction. I repeat, if river is more powerful, then wherever you move with whatever velocity you move, since river is more stronger, definitely river will make you drift in its direction. All right. If you don't want any drift, then naturally you should be stronger. Swimmer or boatman should be stronger. And then the two conditions here. What will be the time of crossing? What will be the time of crossing and what will be the minimum drift? So here, first of all, minimum drift is 0. Here minimum drift is 0 because you want to exactly reach over here. And in the time of crossing, that will be equal to, and this is greater than time of crossing minimum. Okay, obviously time of crossing in the minimum drift will be greater than time of crossing minimum. है ना? Minimum is obviously minimum, least value. Everything else will be bigger than that. So that will be equal to how much time? W by V naught cos phi. W by V naught cos phi. So that will be W by under root में V naught into under root 1 minus sine square phi. Then further you can keep the value of sine phi over here. Sine phi you can keep it over here, and final value will be W by under root of V naught square minus U square. W by under root of V naught square minus U square. So 3 things on this side, 3 things on this side. Make sure you take the screenshot right now. Notes will be attached later on, but I want you to go through it. And this is the last slide. Now after this, we will start with problems. I want you to go through it and I want you to remember all the results right here, right now. Go through it and memorize all the results. Then we will take a quick one-shot recap of everything we have discussed today before starting the problems. Quickly go through everything. When I say remember the approach, remember the approach. When I say memorize the formula, you must be memorizing the formula. Is that all right? Close your eyes, then memorize. All right. Chaliye, let's take a one shot recap, whatever we have learned today. So we started our discussion today with the riverboat problem of kinematics. Riverboat problem. Riverboat problem is basically relative velocity, or more appropriately, I would say, effective velocity based topic. Effective velocity. So boat will be moving inside the river water, and river water will be moving over the ground. So what is the effective or net velocity of boat over the ground that we want to see? Situation, and why it is necessary to see the velocity of boat with respect to ground, because boat or swimmer will start from a point on one bank of the river and they must be trying to reach the opposite bank. So these banks or points are basically on the land, on the ground, right? So boat will be moving inside the water, river water is itself moving over the ground. So if you add them vectorially, if you do the vector addition of boat with respect to water, if you do the vector addition of boat with respect to river water and river water with respect to ground, you will get the first with respect to third. That is the situation. So vectorially you are supposed to add it. Effectively it may be given by the sum or the difference, that depends on the direction. So motion in 1D, if I try to see the river boat motion or river swimmer motion in one dimension, so the downstream and upstream can be two cases. Downstream means along with the flow of the river. So if you add them vectorially and then put the plus minus sign according to the diagram, the effective velocity will be supportive, will be given by the sum. Whereas in case of upstream, if you see this diagram, upstream means opposite to the flow. So boat is moving in this direction, but the river flow is in opposite direction. And here I am assuming that river or swimmer is more powerful in comparison to the river itself. It is moving with higher velocity, I want to say. So in that case, you will be getting V minus U over here. I hope this is clear. Then I have taught you the riverboat problem in 2D. So it is moving in horizontal plane only. There is no effect of gravity, and assuming that the boat or swimmer is not accelerated, every axis, x-axis and y-axis will be considering the, we will be having the uniform motion. Means speed equal to distance upon time, time equal to distance upon speed, distance is equal to speed into time. These basic expressions are valid. Okay. So the thing is, I don't want you to remember any formula here, because it is a general case. We will read the questions language properly. We will make a rough diagram. Then we will do the vector resolution. First of all, we will calculate the time of crossing. Then we will be multiplying it with the effective velocity in the flow of the river, in the direction of flow of the river. And then multiplying the time of crossing with effective velocity in the direction of flow, we will be getting the drift. Okay. Vx multiplied with Tc, we will be getting the drift. Here the angle I have made with the perpendicular, normal to the flow of the river. So few results are in cos, few are in sine, but the moment if you exchange the angle with the flow or opposite to the flow, definitely cos and sine will interchange. That's why I don't want you to memorize any formula. Then I have taken several other illustrations in which everywhere you can see that depending upon the angle, the sine and cos will be in different direction. It's not even necessary that the boatman or the swimmer must be moving in opposite sense. Sometimes it may be supportive. In that case, drift will definitely increase, because here it is plus and plus. A bigger drift you will get. The river's velocity is also trying to provide a drift. The boat's velocity is also okay and is supporting to the velocity of the river. So that's why the drift will be more. It will be given by addition. All right. And at last, I told you these are the two special cases. For this one, definitely I want you to remember all the results. Take one more time a quick recap and memorize all the results. All right. Any doubts? Any other doubts? I hope you have quickly reviewed everything. Now, it's the right time to start with practice problems now. So, the first question that is in front of you, is that clearly visible? Yeah, I think it is clearly visible. I can see on the screen. Right. The question is, the speed of a swimmer in still water is 20 meter per second. The speed of a swimmer in still water is 20 meter per second. The velocity of a swimmer with respect to water, with respect to river, it is 20 meter per second. This can also be written as velocity of boat with respect to river. Okay, or let me take that as V naught or V naught. Okay, swimmer or boat's velocity with respect to river or inside the still water is inside the water is 20 meter per second. But now this water is not still, it is actually moving, right? The speed of river water is 10 meter per second. So velocity of river with respect to ground or U, that is equal to 10 meter per second. Okay, and is flowing due east. Flowing due east means you must be making a diagram over here. So east, west, north, south. This is east, west, north, south if you take the top view. Otherwise, obviously here north and south are not in vertical direction. Obviously they are the directions on the ground, but if you take the top view, it will be visible like this. And if you see over here, this is your these directions, you are somewhere here, and the width of the river is W, and you are having this V point, the V naught value, that the U value is basically 10 meter per second, and the V naught value, what is your intent? If he is standing on the south bank, means you are here, t equal to 0, you are here, and wishes to cross the river along the shortest path. So here, this condition is called minimum time condition, and this condition is also called as shortest path condition. Minimum drift means shortest path condition. Okay, minimum drift is shortest path. Obviously you are moving, so I think I did it at the wrong place. Okay, minimum drift is here. Oh, okay, I'll write it separately. I wanted to write it here. Minimum drift is called shortest path. Shortest path. Minimum drift is called shortest path condition. Okay, that was shortest time over there. This is minimum drift, shortest path. Here, coming back again. So they want you to have the shortest path. Shortest path. Drift is minimum and drift is 0. Drift is minimum and drift is 0. Where in which direction, where should he should he make the strokes? So the question again, the speed of swimmer is given to you, the speed of the river water is given to you. The swimmer at t equals to 0 is standing on the south bank over here. Definitely you want him to make the strokes like this, say V naught. Suppose this angle as phi, and all the 4 options are west, west, west. So towards west, in west direction, with what angle you are making, how much angle you are moving in the west direction, like that. With respect to north. With respect to north means from the north, how much angle you want to make towards west, they are asking. Suppose that is phi. So what I'm going to do over here, I'll say this will be V naught cos phi and this will be V naught sin phi. Since your intent is to move exactly on the opposite bank, definitely these two components must be same. Okay, examiner is saying that the swimmer is on the south bank, you want to reach exactly opposite to the another bank, which means and wishes to cross the river along the shortest path. Shortest path means minimum drift, you want to exactly reach the opposite point. With respect to north, in which direction he should make his strokes. So as diagrammatically you can see, from the north he should be making the angle in the west, but how much angle? So you need to balance them. You will say here, for x to be minimum, which is equal to 0, that is shortest path condition. What we can have over here is, you will say V naught sin phi. If they say with respect to, like, from west, what is the angle made in north direction? Then they will be asking you this angle. from north, what is the angle made in west direction? They are asking you this angle over here towards west. So V naught sine phi must be equal to U, must be equal to U. This implies sine phi must be equal to U by V naught. This V naught is what? This V naught is 20, this U is 10, 1 by 2. So basically you get sine phi as 1 by 2, or you can say phi is equal to 30 degrees. 30 degrees west. Phi is equal to 30 degrees west. See, option A you got. Option A you got. I'll show you the standard result one more time. See, here it was sine phi is U by V naught. U by V naught. Phi is sine inverse U by V naught. U must be less than equal to V naught. That's what the similar situation is here. But instead of directly applying the formula, I just tried to show the case once again. So I read the problem, draw the diagram, put the condition. Entire thing is based on vector resolution as well as relative velocity. Is that clear? The rare one, yeah. Sorry, yeah. The rare one, whatever you are asking is not related to the session right now. I'll take the doubt separately, okay? Right. Chaliye, any other doubt related concerning the topic, or is that clear, dear? All right. Now, let's move on to the next one. Next question is, a person aiming to reach the exactly opposite point. See, the same situation, aiming to reach the exactly opposite point on the bank of stream is swimming with a speed of something at an angle of 120 degrees with the direction of the flow. At an angle of 120 degrees with the direction of the flow. So this is the speed of water in the stream is. So they are asking you, what is this value? U is question mark. At an angle of 120 degrees with the flow, 120 degrees with the flow, this is the V value, which is 0.5 meter per second. Okay. And they are asking you then what is the speed. So obviously you want to reach the opposite one. So let me draw this line. So if overall is 120 degrees, can I say this angle, it should be 90 plus 30 degrees. Overall angle, if it is 120 degrees, then this should be 90 plus 30 degrees over here. So I will say this will be V cos phi and this will be V sin phi. V cos phi, V sin phi. And I would say in order to reach the exactly opposite point, see, in order to reach the exactly opposite point, to reach exactly opposite point, to reach exactly opposite point, you will say that is x is minimum. And how much it is minimum? Minimum drift is 0. See, interestingly, minimum time condition mein time obviously will not be 0. It will be something. But in minimum drift, the drift minimum is 0. To reach exactly opposite point, the drift should be minimum. It should be 0. So what we have is V naught sin phi or V sin phi over here. That must be equal to U. This implies U will be equal to V value. V value is how much? 0.5. And this phi value is 30 degrees. That is sine 30 degrees. Sine 30 is 1 by 2. So this is 0.5 and it is also 0.5, 1 by 2, and hence the final answer is 0.25 meter per second. 0.25 meters per second. Similar, easy problem. Today, I think number of learners are relatively very less because the batch launches they are here in different centers. All right. No worries. The students who are still connected can try to answer. Remaining, I believe, will be looking for it after the session. Is that clear? Let's move ahead. So the width of river is 1 kilometer. The next problem is the width of river is 1 kilometer. The velocity of boat is 5 km per hour. The boat covered the width of river with shortest possible path in 15 minutes. Then the velocity of river stream is shortest possible path you have covered in 15 minutes. And they are asking you the river velocity. So for in shortest path, that is drift is minimum and the minimum drift is 0. drift is minimum and this minimum drift is 0, the time of crossing is given by, I told you this formula, W by under root V naught square minus U square. W by under root V naught square minus U square. In this formula, the time of crossing is given to you, although the options are in kilometer per hour, so you must be converting it in hours. The width of the river is given to you, that is already in kilometer. The velocity of river stream is required. The boat is also given to you, and the velocity of river stream U is required over here. So definitely there are 4 parameters and a standard formula. Fit the values of 3, get the values of the 4, get the value of the 4th. So time of crossing is 15 minutes. 15 minutes means 15 by 60 or 1 by 4. 15 by 60 or 1 by 4. W is already 1 kilometer. Under root V naught square. V naught square is 5 kilometer per hour. Here it is 5 square minus U square. Obviously you are capable of solving it ahead. So what you can do is just multiply, cross multiply. It is under root 25 minus U square, that is equal to 4. This implies squaring both sides. 25 minus U square is 16. Exchange the sides. 25 minus 16 is equal to U square. This implies U square is equal to 9, or U value will be equal to 3 kilometer per hour. That's a 3 kilometer per hour value. Alright, and hence the correct option is option A. Is that clear? You can see that. I've just taken this problem because majority of students, they have a tendency to forget this particular formula. So when time of crossing is minimum, it's non-zero, it is W by V naught, and drift will be U into W by V naught. But when drift is zero, drift minimum, when drift is minimum, drift minimum is 0. So the only formula you need to remember in minimum drift is time of crossing at minimum drift, and that is W by under root of V naught square minus U square. Alright, Chandana, Niharika, remaining students, I think it is clear for you. Let's move on to the next one. Yeah. The velocity of a boat in still water is 10 meter per second. I'll keep writing the informations provided. The velocity of boat in still water, velocity of boat with respect to river, which is V naught, that is equal to 10 meter per second. If water flows in the river with a velocity of 6 meter per second, velocity of river with respect to ground or U, that is equal to 6 meters per second. What is the difference in time taken to cross the river in the shortest path and the shortest time? So they are asking you delta T. They are asking you delta T, time of crossing in the shortest path when X is minimum, minus time of crossing when it itself is minimum. I repeat, they are asking you the difference in time taken in the shortest path and in shortest time, minimum time. The shortest path means when X is minimum and time itself is minimum. That is the second case. So basically I have taken this problem because this is a problem that involves both the special cases I told you to remember. Otherwise in riverboat problem, you are not supposed to memorize. But for the special cases, I told you to memorize the formula. It's a special problem involving both the special cases and all the formula. So what is the time of crossing when X is minimum? Just now we have seen that formula. That's W by under root V naught square minus U square. And what is the time of crossing for minimum time condition? That is W by V naught. W by V naught. I think everything is given to you. The width of the river is 80 meters. The width of the river is 80 meters. That is also given to you. Everything is in SI unit, meter per second, meter. So the final options will also be in SI. I think you can do that. That's 80 by under root V naught square minus this square. So that's 10 square minus 6 square minus 80 by V naught. V naught is 10 over here. All right. So that is 80 by Pythagorean triplet, 100 minus 36. That's 64. 64 root is 8 minus 80 by 10. So 80 by 8 is 10 minus 80 by 10 is 8. This implies delta T is equal to 2 seconds. Delta T is equal to 2 seconds. That's what you got. Is that all right? And hence the correct option over here is option D. Okay. So a simple problem, but a very nice problem because it is a very nice problem because it involves both the special cases, all the formula to be memorized. If you don't remember those formula, that's going to take a lot of time. Okay. Let's move on. So basically, difficult questions in the NEET exam are not only the questions that involve a lot of maths or involve, deep concepts. No, if it is a very lengthy solution, time taking, or a problem which involves the expressions that students generally tend to forget, these problem models also come in the difficult category. That's what I'm trying to make you prepare for. Okay. Let's move on to the next one. Similar problem. A boatman finds that he can save 6 seconds. This time, similar problem that involves both of them, but some other parameters are given and some other parameters are required. So, boatman finds that he can save 6 seconds in crossing a river by quicker path than by shortest path. Quicker path and shortest path difference, this time it is 6 seconds. If the velocity of boat and river be respectively this and this, then the river width is. So, I would say delta t is again when time of crossing, when x is minimum, this will be the shortest path, minus time of crossing when itself is minimum. So you will say this is basically shortest path as per the language, and this is basically the quickest path. Shortest path, quickest path. All right. This implies delta t will be equal to w by under root v naught square minus u square minus w by v naught. Okay, these are the values. Now you see, then river width is, they are asking you the river width. They are giving you delta t 6 seconds, v naught 17 meter per second, u 8 meter per second, 17 meter per second, and they are asking you w. They are asking you w. I hope you can solve it further. And get me the value of w. Can I leave it on you? Easy, no? I just have taken it another problem of the same, so that if you will do it yourself, definitely you'll remember it. Okay. You can take the screenshot of this because I want you to try this. And another problem also I would suggest you to try. Take a screenshot quickly. All right. Take a screenshot of this also. I have already highlighted the answer for you, but I still want you to try this. Okay. One problem, 2 problems for this day. Just quickly take the screenshot and then you can try. Taken? Chalo. So you try it on your own. Answers can be discussed, and definitely here the answer is already highlighted. And it was a problem in which you can easily calculate that. That's it from my side today. I hope you have understood. These are not the problems to be done. Okay. That's it. That's it from my side today. I hope you have understood the river boat problem. Similarly, tomorrow when we will be meeting, we will be talking and emphasizing about another common model in which a lot of students feel difficulty. But after tomorrow's session, you will not find it difficult. You will enjoy doing those problems. That model is rain umbrella problem. So tomorrow we will dedicate the discussion to rain umbrella model, and if the time permits, some other models, flag fluttering model, wind and cyclist model, the ship model, minimum separation and all, whatever I have told you. So that will, successfully complete our relative velocity topic. All right. Till then, keep smiling, take care of yourself, and do follow the rule of revision. All the best. Bye-bye.